Hello and welcome to Chemical Change, so GCSE exam questions. So all of these questions have been taken from actual GCSE exams, so they're taken different exams, so you might see a number at the top which doesn't go in order because it's taking different GCSE exams, okay? So number one, this happens to be number one, this one. When solid sodium chloride is mixed with water, sodium chloride solution forms. What name is given to the process of mixing a solid with water to form a solution? So solid with, so think about that. So crystallizing. So crystallizing is when you leave a substance to dry out and it is crystals form. So it's not that one, is it? So diluting is two liquids. Okay, think about sort of like diluted orange juice. Dissolving, yeah, possibly. Melting, no, it's not melted, so it's mixed, so it's dissolving, isn't it? So you dissolve sugar in water. Sodium reacts with hydrochloric acid to form sodium chloride and hydrogen. Write the word equation for this reaction. So it's the words, it's not a chemical equation, the word equation. So all you have to write is sodium. It's actually quite nice, easy marks to get in an exam. So sodium. And all we need to write is plus hydrochloric acid. Okay, hydrochloric acid goes to sodium chloride and hydrogen. So sodium chloride plus hydrogen. Okay, that's nice, easy marks to get there. The hazard symbol shown in figure 1 is used on containers of sodium. What is the meaning of this hazard symbol? Okay, so this is probably quite an easy one, isn't it? Flammable. Okay, so for GCSE, you do have to learn the hazard symbol. So other ones can come up, the corrosive can come up, oxidizing, toxic, harmful to the environment can come up. Okay, so you need to learn those if you've forgotten them. Hydrogen has one electron in its outer shell. So it's an outer electron shell. Figure 2 shows the incomplete dot and cross diagram of a hydrogen molecule. Complete figure 2 to show the electrons in a covalent bond between the two atoms of hydrogen. So they're both hydrogen. So we're going to look at one. So this is probably the simplest dot and cross you can draw. So a cross and a dot. So use different electron symbols, even though they're all electrons, to show they come from different atoms, even if they're the same type of atom, to show they're from different atoms, just to make it visually easier to tell. The pH of sodium chloride solution was measured. State what could be used to measure the pH of a solution. So the best one here is universal indicator. It's one you probably have used before. There are other methods. You can have pH probes and things as well. You probably haven't used those yet. So electronic things. So that would be an answer as well. But probably the one you know is universal indicator, so like a liquid. Or paper. Sodium chloride solution is neutral. Give the pH of the solution. So if we've forgotten pHs, you have one, it goes up to 14. So 1, 2, 3, 4, 5, 6, 7. So 7 is neutral. All of this is acidic. Okay. So strong acid, 1 to weak acid, and 8, 9, 10, 11, 12, 13, 14. So this is basic or alkaline. So alkaline is a basis in water. Okay, so it said neutral, so it is 7. You have to also remember the colours. So here it goes from red, so all the way to sort of, it goes through orange, yellow, all the way to like a light green. This is actually funny because I'm writing green. This is actually green. And this goes from like a dark green all the way blue to purple at this end. So again, if you've forgotten that, you need to look that up because they could ask that question what colour it will be as well. In industry, ammonia is manufactured by reacting nitrogen with hydrogen. Give the name of the industrial process used to manufacture ammonia. So it's one you have to know the name. So it's the Haber process, named after the person who invented it. Haber process. Write the word equation for this reaction, including the correct symbol to show that reaction is reversible. So again, it's just another word equation. Again, we're actually told, okay, what the reactants are. Nitrogen and hydrogen. So here we get another mark for the symbol, reversible reaction. So the arrow goes both ways, goes to ammonia. Okay, that's actually nice 3 marks to get there. The formula of ammonia is NH3. State what the formula of ammonia shows about the number of nitrogen atoms and the number of hydrogen atoms combined in a molecule of ammonia. So there is 1 nitrogen atom because there's not a number next to it. So it just means there's 1. And 3 hydrogen atoms. Okay, that's all that shows. Most of the ammonia manufactured in industry is used to produce fertilizers. A fertilizer is made by reacting ammonia with nitric acid. What is the name of this fertilizer? Okay, so ammonia with nitric acid. So ammonium nitric, that doesn't make any sense. Ammonia. See, this is where it's going to trick people, isn't it? Ammonia nitrate or ammonium nitrate. So when it becomes an R, it goes to ammonium nitrate. That's what's going to trick people. So explain the importance of fertilizers in farming. Okay, so it sounds like a biology question, doesn't it? But this isn't a chemistry paper, so they can mix it a little bit. Okay, so it could be asked a little bit in biology too. So we'll mix it up a bit. So plants need specific minerals. So it's minerals from the soil, remember? Minerals from the soil, such as nitrates, like we see here. Another one for photosynthesis, magnesium, you might know. To grow. So nitrates are for proteins, and for photosynthesis. So fertilizers increase yield, so amount of crop that's produced, and how quickly the plants grow for food production. Okay. Only 2 marks, so it's not too involved. In the 19th century, Mendeleev arranged the elements known at the time to form his periodic table. Mendeleev's periodic table is different from the modern periodic table. State one difference between Mendeleev's periodic table and the modern periodic table. So actually there's a clue in the question there, wasn't there? It gave you an answer. Elements known, so more elements have been discovered since. So more elements have been discovered. That's the easiest one. In the modern periodic table. Okay. Aluminium oxide reacts with hydrochloric acid to form a salt and water. State the name of the salt formed. So aluminium oxide, hydrochloric acid. So it takes the first bit, takes the name of the metal, aluminium, how it always works. And the second takes it from the acid, aluminium nitrate. In this reaction, oh, made a mistake. I was talking about nitrates, got distracted. So yeah, that's hydrochloric acid. Right, so that would be not. Yeah, I was talking about nitrates and it was still in my brain. So always read it twice. You made a mistake then. So it's always go back and read. There's a bit of a lesson in watching this to go back and read something. So aluminium, what's the hydrochloric acid? So it's ammonium chloride from the hydrochloric. Yeah, that is a lesson to always go back and read what you've done. It's easy to make mistakes. In this reaction, aluminium oxide is a base. Okay, we talked about bases a little bit before, a few minutes ago. State the type of reaction that takes place when an acid reacts with a base. It's a neutralization reaction. Gallium, symbol Ga, is in the group of the modern, is in the same group of the modern periodic table as aluminium. The formula of aluminium oxide is Al2O3. Predict the formula of gallium oxide. So it's in the same group, so it forms most likely to form the same ions. Okay, so it will be very similar. Ga2O3. It's in the same group, it's very likely to form very similar compounds. Gallium oxide has a very high melting point. Gallium oxide does not conduct electricity when solid, but does conduct electricity when molten. What type of substance is gallium oxide? Let's read that through again. High melting point, does not conduct when solid, but does when molten. Okay, so we've either got a giant covalent, ionic, metallic, or simple molecular. Well, simple molecular never conducts at all, so it's not that one. Metallic, it's not a pure metal. Okay, so we've got giant, covalent, or ionic. So does not conduct electricity when solid, but does conduct electricity when molten. So molten, that lends it to being ionic, doesn't it? Ionic. Some metals are found in the Earth's crust as uncombined elements. Reactive metals are found in ores. So an ore is a rock which contains the metal that can be extracted. In ores, metals are combined with other elements. Which of these metals is found as the uncombined element in the Earth's crust? So we just saw aluminium reacts with things. Gold, possibly, doesn't react with very many things. Potassium, no, very reactive. Zinc does react. So it's gold. So that's why you have gold jewellery, because it won't react with your skin and other things. Okay, there are lots of jewellery made of gold. So give 2 advantages of recycling metals rather than extracting metals from their ores. So there's lots of different, so ores you have to actually physically dig up. So recycling metals, so it is, so recycling is better for the environment as mining ores, so to actually dig them up, but mine them, can destroy ecosystems. And pollute the environment. Also, recycling can be cheaper. So the good word for that is more economical. Than mining and processing. It's a processing ore as well, processing the ores. Okay, there's other examples you have. In one stage of the extraction of lead from its ore, lead oxide is heated strongly with carbon. The equation for the reaction is 2PbO plus C, that's carbon, goes to 2Pb plus CO2. Explain using this equation which substance has been oxidized in this reaction. So, which one's gained? So, lead lost oxygen from it. It's formed lead. So, this is lead oxide, and that's just lead, Pb, plumbus in Latin. So, carbon has gained an oxygen. So, carbon has been oxidized as it has gained 2 oxygen atoms to become carbon dioxide. Okay, so that's I'm going to finish the video there. So going to say good luck on your exams and hope to see you in another video. Thank you and goodbye.